Okay, today we're going to learn about converting from one atom in a compound to another. So, chemical formula tells us the types and number of atoms present in a compound. And so, for example, if we have this compound right here, that means we have one carbon atom, two chlorine atoms, and two fluorine atoms because it's supposed to be the Cl2F2. So, one carbon atom, two chlorine atoms, and two fluorine atoms. But we can also relate that to moles, because if we had 1 mole of this compound, then that would mean we had 1 mole of chlorine out of this compound, 1 mole of carbon, 2 moles of chlorine, and 2 moles of fluorine out of that compound. So you can actually make ratios, which I'm going to do on the next slide. So if I had CCl2F2, just like on the previous slide, let's make a ratio. In 1 mole of CCl2F2, we have 2 moles of chlorine. So that can be added to our conversions. You could relate it to any atom in a compound. And you can even relate the atoms to each other. For example, 2 moles of chlorine from this compound would be 2 moles of fluorine. But only for this compound. Another compound might have a different ratio. So we're going to add to your mole guy. And we're going to be working right here. Moles of an atom in the same compound. So I'm going to make it a little bigger. If we're going from moles to moles, we would use a mole ratio. Just like we just did. 1 mole if we have x to the 2, y to the 3. 1 mole of x to the 2, y to the 3 makes 2 moles of x. Or 2 moles of x would be 3 moles of y. And you could flip both of those. You could put either thing on top or bottom. You turn this over or this one. Just, it depends on what you start with. So here's an example. How many moles of fluorine are in 5.5 moles of CCl2F2? So start with what you know. This is what we know. And then we make a conversion. So moles of Cl2F2 is on top. So moles of CCl2F2 has to go on bottom. And we're going to moles of fluorine. And in 1 mole of this compound, there are 2 moles of fluorine. So we would get 11.0 moles of fluorine as our answer if we multiply across the top. Here's another example. How many aluminum moles are in 1.25 moles of aluminum oxide? So start with what you know. But we have to write a formula for aluminum oxide. So Al3 plus O2 minus, and what do we get? Al2O3. That's aluminum oxide. So now 1.25 moles of Al2O3. And in 1 mole of that, Al2O3, we have 2 moles of aluminum. So for our answer, multiply across the top and you get 2.50 moles of aluminum. How many oxygen atoms are there in 3.6 moles of aluminum oxide? Okay, so again, we just learned aluminum oxide, Al2O3. So if we start with 3.6 moles Al2O3, and moles of Al2O3 has to go in bottom, and moles of oxygen has to go on top. Right, so if we have 1 of these, then how many oxygens do we have? 3. And we multiply across the top, and we would get 10.8 moles of oxygen. Okay, here's a little harder example because now we're going to go all the way to atoms. So we're still starting with aluminum oxide, 5 moles aluminum oxide. And we have to have moles of aluminum oxide on bottom. And we're going to oxygen, but if you look at the mole guy, you can't convert directly from moles of aluminum oxide to atoms of oxygen. You have to make a pit stop in the middle. So we're first going to go to moles of oxygen. And for every one of these, there's 3 moles of oxygen. Then in 1 mole of oxygen goes on bottom, because we're now in moles of oxygen. And then we're going to atoms. So what number goes up there? In 1 mole, there are 6.02 times 10 to the 23rd atoms. So now you multiply across the top and see what you get. So I did that on my calculator, and I got 9.03 times 10 to the 24th. And don't forget to label atoms of oxygen. Okay? So try it on your own and make sure you get the same answer. And that's all there is for today.